Hello, I am Emir Kerem from Bilkent University. This is my PHYS-101 project. In this experiment, I investigated the relationship between spring extension and centripetal motion. My aim was to measure the spring constant using both static and dynamic methods and to compare the results. When an object moves in a circular path, there must be a force pulling it towards the center. In the experiment, this force is provided by a stretched spring. By measuring how much the spring stretches, we can calculate the spring constant. I used a static method, adding masses and measuring extension, a dynamic method, rotating the mass and measuring its period. The equipment I used, a spring and hanging mass, a pulley, meter ruler, masses. In the dynamic part, I measured the time for 5 revolutions. In the static part, I added different masses and measured how much the spring stretched. First, I used the static method. I hung different masses on the spring and recorded the extension. Then I calculated the force using F equals to mg. The spring constant was found from K equals to F over delta x. Static method errors. Ruler reading, parallax. Small extensions, larger relative uncertainty. Mass labels not exact. Spring not perfectly vertical. From the static method, I found that the spring constant was around 3.10 newtons over meter. This is my static graph. It shows a very strong linear relationship between force and extension. R square was almost 1, which means the data follows theory well. After that, I used the dynamic method. I rotated the mass in a horizontal circle using the pulley. I measured the time for 5 revolutions, so the period was t equals to t5 over 5. I also measured the radius and the spring extension during rotation. Dynamic method errors. Reaction time with video. Friction in pulley and air resistance. Radius not perfectly constant. Small extensions during rotation. From the dynamic method using the graph of t squared versus r over delta x, I found 2.69 newtons over meter. This is my dynamic graph. The trend is still linear, but the data has more scatter. R squared was around 0.7, which is reasonable for real motion. The difference is about 14%. This is expected because the dynamic experiment has more losses. In conclusion, both methods gave similar values for the spring constant, static 3.10, dynamic 2.69. The results are close, so the experiment was successful. This shows that the stretched spring does provide a centripetal force in circular motion. Thanks for watching.